Hi everyone. So finally we are live. As I promised that I'm going to offer a GATE crash course on all these subjects, right? So this is going to be a very first subject that I'm going to start, for all the branches, for electrical engineering, for electronics, and for instrumentation, right? So you can say this is going to be a kind of Diwali gift, okay? And these sessions are going to be an eye-opener session, you can say, right? If you're going to follow these sessions, right, for next 40 to 45 days, you're going to learn many things. And the kind of confidence you're going to gain, the kind of, you can say, the kind of concept you're going to gain, the kind of insight you're going to gain is, there is no comparison at all, right? So I will be sharing my entire experience, what exactly I think about network theory and how we have to approach to network problems, right? So, and sometimes we also call it circuit theory, or you can say basic electrical engineering, right? So yes, please join fast so that we can begin the session. I think I have informed everybody to join, right? So though if nobody is going to join, still I'm going to offer these sessions because in future many people can watch these sessions, right? Yeah. So yes. So what I'm going to talk basically is in this GATE crash course, okay, that I'm going to tell you now. So the very first subject that I'm starting is the network theory, right? Network theory. Okay. Or we call it circuit theory, right? Or you can say the basic electrical circuits, right? Basic electrical circuit. So how this subject is going to be very useful for you all, right? In the last minute, okay? This subject is going to be very useful in the last minute. I'm very sure that many of you are not familiar with those techniques, okay, which can help you solve any question in less than, you can say, 1 minute or 2 minutes, right? So you're getting lost into content which are available in YouTube, right? So in this session I'm going to show you, okay, I'm going to show you that these are the things you should know, okay, before you start solving PYQ or any subject, because I have seen many students, many questions are there which are really controversial. I mean, the moment they see the question, they post it, okay, somewhere down the line, right? And they get the solution, they are happy, right? But I'm going to give you my generalized understanding of network theory or circuit theory, or you can say basic electrical circuit. So this course is going to be uh, help you, going to help you to understand analog circuit design, because in future I'm going to conduct analog circuit, right? Analog circuit sessions, as well as these sessions are also very useful to crack any sort of interviews, whether you are preparing for analog profile role, or you can say any sort of role, right? Okay, so after gate also these sessions are going to be very useful, right? So I'm very sure that many of you might have studied network theory, okay? So I will be giving you the quick recap in this season, right? Because this is the lecture number 1, okay? And lecture number 2, or you can say lecture number 3 will be on pure problem solving, right? Okay. So please join fast so that we can begin the session, and send me hi so that I will come to know, yeah, those people have joined, right? Fine. So yes, so let us begin here. So what I'm going to talk about basically is, in network theory, we have to talk about current, what is voltage, okay, what is electrical elements, okay. You should be familiar with all these things. In fact, I requested everyone to recap, okay, before 9 p.m. Okay, so in fact, I did entire revision of network theory before I'm presenting in front of you, right? So we will talk about basic electrical circuits. We'll talk about KCL, KVL, right? And what are the important thing in KCL, KVL you have to keep in mind while applying them, right? And when you should apply node, when you should apply, mesh, okay? No, when you should do nodal analysis, when you should do mesh analysis, right? And there are many things, like we'll talk about voltage source, current source, okay, independent sources, uh, controlled sources, okay, and where we use these controlled sources in our analog circuit, because you know that nobody is going to tell you that, yeah, these are the controlled sources and they are useful in amplifier designing, right? Nobody is going to talk about, right? So I will be telling you all these things, right? You have to keep in mind, understand. So then we'll talk about mutual inductance, linearity of the element, right? Okay, like many people get confused that if any network is there, suppose any black box is there, inside that black box, if there is a dependent source, right? So many people think that, yeah, the circuit has become non-linear, right? So we have to talk about what is linearity basically. In fact, many people study linearity in their signal and system as well, right? What is the linear system and all. And we'll talk about series connection of voltage source, okay, and we'll talk about parallel connection, okay, series and parallel connections, okay, element in parallel, okay, and we will talk about extreme cases, like we'll talk about open circuits and the short circuit, okay, what is the meaning of open circuit, what is the meaning of short circuit, right? And as we know that in electrical engineering there are two things, that is voltage and current, right? So we talk about power, okay, when we take the product of voltage and current, that is going to be power, right? So these things are going to be discussed, right? Power and energy absorbed by electrical elements, power and energy in the resistor, power and energy in the capacitor, power and energy in the inductor, right? Power and energy in the voltage source, power and energy in the current source, right? So these things we are going to talk about, right? And then we'll talk about number of independent KCL equations. Suppose you have got any network or a circuit, okay? We will define circuit in a while, don't worry. So suppose you want to apply KCL over there. So how many nodes are there? How can you find that? Okay, so you just find out the node, okay? Then how many independent KCL equation will be there? So we always say n minus 1, right? And number of independent KVL equations, okay? And the branch relationship, okay? And analysis of circuit with single independent sources, analysis of circuit with multiple independent sources, okay, using superposition, right? So if any circuit will be given, there is only one single source, you can say independent source I'm talking about, right? So we are going to apply simple, we are not going to use superposition, but there are so many independent sources, then we can use superposition, right? Like one guy will be acting at a time and we have to deactivate all other guys, right? So those things I will talk about. Then we'll talk about like when there is a controlled source, okay, so how to apply KCL and KVL super node analysis. Then we'll talk about planar circuit, okay, where we can apply KVL and all, mesh analysis we call it, okay. Then we will jump to theorems, right? So Thevenin theorem we will talk, okay, it plays an important role in analog circuit. Norton's theorem, right? Okay, and then we'll talk about two-port networks, right? So many two-port networks are there, like, we'll talk about G parameters, okay, various parameter of two-port networks, okay, reciprocity, understood. Then we'll talk about transients, we call it like RC circuits, RL circuit, RLC circuits, right? All those things, right? So these are the things that I'm going to focus. Fine. So let's begin the session here, guys. The very first question in my mind is that, or in fact, everybody might be having, what is this electrical circuit? Electrical circuit, right? That you should know. What is this electrical circuit? And this, the weightage of this subject is, around 10 to 12 marks, right? But these 10 to 12 marks are going to, in fact, understanding these subjects properly will help you to understand entire analog circuit, right? That's what I would say, okay? So 10 to 12 marks you will get, right? But if you're interested in analog circuit deeply, right, so you should be good at electrical circuit, right? So what is the meaning of electrical circuit? Can somebody tell me? So electrical circuit is nothing but what? Suppose you have got a electrical elements, let's say resistor, inductor, capacitor, okay, and sources, okay. So you just connect them. So interconnection of electrical elements, you can say, or you can say electrical components. Interconnection of what? Electrical components. Okay. Is going to be electrical circuit, right? Okay, so this is very important to keep in mind. Interconnection of what? Electrical components, right? Okay, this is very, very important. Okay, so once you will connect those electrical components, what will happen over there, right? Basically current is going to flow, okay. The voltage will be there across some element or some component, you can say. So how current flows in the wire? Okay, so I am not going to go into, you can say, deeper physics or something. You should always know that if charge is moving, right? If there is a charge, right? So if charge is moving, then only there will be a current, right? So always remember that charge will be there and charge is going to move. And now the question is how charge moves, right? Okay. So I think many of you might have seen in electromagnetic that there is an electric field, there is a magnetic field, right? So when there is an electric field, okay, so the charge is going to produce electric field. Everybody knows those are the sources, okay? And if charge moves, current is there, right? So we have to understand what is current, what is voltage and all. This is basic definition that you should know, okay? What is the electrical circuit? Electrical circuit is nothing but interconnection of electrical components, okay? You can connect, you can take, suppose this is going to be electrical circuit, right? Okay, this is going to be electrical circuit, understood? So this is going to be electrical circuit. Just we have interconnected all the elements, right? So but first of all, what I will talk about is, we will talk about what is this electrical current, electric current, you can say. What is this electric current? Okay, and we don't have to talk about those things like what is the difference between circuit and the network, all those things, because everybody knows these things, okay? So basically we have to quickly revise, है ना? So yes, so what is current? Basically everybody knows that current is nothing but rate of flow of charges, right? So current is what? Rate of flow of charges, right? That is going to be dq by dt. How we express rate? Rate we express with the help of derivative, right? So derivative is nothing but what? Slope, right? dq by dt, dq by dt means rate of change of charges, right? That we have to understand. So rate of flow of charges is going to be dq by dt, and this is going to be a current, right? We define current. Or you can also say that suppose now suppose you have got a closed surface here, okay, kind of surface, and suppose there are charges which are moving like this, okay? So this is very important. So current through the surface, okay? Basically we always talk about current through the surface, right? Current through the surface, okay? Current through the surface. So how many charges are passing through this, okay? You have to remember this, okay? How many charges, okay? How many coulombs are passing through this this surface per unit time, you can say, or per unit second. So suppose 1 coulomb of charges, okay, passing through this in 1 second, so that is going to be 1 ampere, right? So always remember current is what? Charge upon time, or rate of flow of charge. This is the basic definition that one has to know. That's it, okay? This is very important definition, right? So if you know this, what is current? How many charges are passing through a kind of area you take, okay, in second, in 1 second, or okay, that is very important to remember. So this is going to be a current, okay? So basically in our case, if we design a circuit, right, so there will be a wire, right? So wire are going to be represented like this is kind of a wire, and currents are going to flow like this, okay? So you see, we always put direction, okay, whenever we want to show that there is a current, right? So we always say that, yeah, there is a this arrow indicates that current is going to be flowing, right? So always remember, whenever we are going to show in any circuit current, right, so we have to show with the arrow here, right? This is a current, okay, and we can say 1 ampere current is flowing from A to B, right? From A to B 1 ampere current is flowing, right? Suppose I say that from B to A, how much current is flowing? Suppose this is a direction examiner has specified, okay? So if somebody is asking how much current is flowing from B to A, so you have to say -1 current. From B to A, -1 current. From A to B, 1 ampere current is going to flow, right? Because the direction is going to change, right? That is very important to remember. Understand? So the total current through the wire, what we always consider is, suppose this is a wire. Wire is nothing but a conductor. This is simple wire, you can say. Wires are nothing but what? Conductors, okay? So I think these things are very basic thing. I need not to explain, okay? But you have to quickly look at this, okay? When charges move only through the wire or element, then only there will be a current. Understand? So what we are ignoring in this case? We are ignoring the distribution of charges, right? When we say that charge is moving from A to B, so current will move from B to A, right? suppose electron is moving from A to B, right? But we always define current with respect to positive charge. That is very important to remember. So what we are understanding here is, suppose charge is moving from A to B and that is a positive charge. So what you can say, current is going to be flow from A to B, right? Okay. So here we don't have to consider the charge distribution and all. Simply we say that current is flowing from, suppose this is a kind of electrical element. We don't know what kind of element is this. It can be R, it can be L, it can be C. ठीक है, ये R हो सकता है, ये C हो सकता है. ओके, ये आपको याद रखना है. ठीक है, तो करंट आपका कैसा मूव करेगा, A to B. ठीक है, तो आप बोल सकते हो 1 एम्पियर करंट इज मूविंग फ्रॉम A to B. Understood? So this is simply a current, and the definition of current is what? dq by dt. बस इतना याद रखो, that is more than enough, right? And all the definition I have told you, right? So when charge move only, that is going to tell you the current. Okay, so as I told you that, what you have got a kind of wire, and you can say that 1 coulomb of charge is, you can say moving, right, from A to B per unit time. So that is going to be a current. So we don't write like this, we say 1 ampere simply, right? So this is the very basic thing. So 1 ampere current is flowing from A to B, okay, through the wire. Okay, so for current we are going to use through, right? And for the voltages we will say that across, okay, across, understand? And minus 1 ampere current through B to A, okay, through the wire. Now the question is, how do we measure current, right? How do we measure current? Current को कैसे measure करते हैं, ये आपको पता होना चाहिए, right? How do we measure current? We always put one ammeter, right? देखो, that is also very important. So suppose this is a wire, and how can we say that there is a current? So you just break somewhere, right? You can break here, okay, and you can connect 1 ampere ammeter, right? Current ammeter. So it will tell you there is a current, okay, you can say. And remember that you have to make sure that this current ammeter, ammeter is basically a device which measures the current. So make sure that this has series resistance which is 0, okay. The resistance should be always 0 in case of ammeter, right? So that it should not disturb anything, okay. Because simply you have to, what you have to do, you have to measure the current, right, in the wire. So you will put one ammeter, but ammeter should not affect anything, right? So you have to make sure that the series resistance of the ammeter should be always 0. That is very important to remember, okay. Ammeter have, you can say, 0 resistance in series. Okay. Why? What is the reason behind this? What is the reason behind that? So that your circuit should not be disturbed, okay. You can simply find the current, understand? In fact, these concepts are also used in analog circuit, right? When we discuss about feedback amplifiers and all, right? Okay, because there also we sample voltage, we sample current from the output, and we connect back to the input, right? So we always use the ammeter and all, right? So आपको इतना याद रखना है. तो ammeter का जो series resistance होता है, that is 0. In case of voltage, when in case of voltmeter, we will apply voltmeter across certain element, right? So the resistance, we have to make sure that the resistance is infinite or very high, so that it should not disturb, okay, entire circuit, okay, understood? This is very important. So current, I think everybody knows what is this current, okay. Now the question is, what is voltage, right? So voltage is nothing but what is voltage? Can somebody tell me what is going to be voltage? Yes. So voltage is nothing but what? We always say that, okay. I'm not going to be going to get into detail. I will say that simply, suppose this is a element here, right? And across this we are going to put V, right? What is this V? V is nothing but what? We will say that here the potential is V1, here the potential is V2, okay. Actually we can explain this concept using electric fields and all, right? One charge will be there in the electric field, and that charge is going to move. The amount of work that charge is going to be done, performing, right? So accordingly you can define the voltage, right? So voltage will be nothing but what? dW, you can say, okay. I will tell you the definition here, just wait and watch, right? So it will be nothing but what? The voltage is going to be dW by, okay, dQ, okay. This is the definition of voltage, you have to remember, right? In case of current, dq by dt in case of this. So suppose you want to take this 1 coulomb of charge from one point to another point, right? So you have to do how much work? So you can say 1 joule, or you can say 1 joule you are the energy you are going to spend, right, to bring one charge from one place to another place. That is going to be a voltage if you take the ratio, right? So this is how we represent voltage. Remember, suppose this is the electrical element, so voltage is going to be represented with the help of these polarities, plus to minus, right? Plus to minus. And someone is going to ask you what is this voltage, so V is going to be V1 minus V2. The potential difference is basically the voltage, right? Potential difference, okay, potential difference, okay. The potential difference is going to be a voltage, right? So always remember this, right? So we will take one you can say one element here, and if I say that there is a current flowing I, right, so we always say that there is a voltage across this element, right? Okay, it can be resistor, it can be capacitor, it can be inductor, right? So we always use this kind of a representation. Take one element, current is flowing, so we have to show this current with an arrow, and there will be plus minus voltage, right? Okay, so in future we will discuss one convention that is known as passive sign convention, right? Passive sign convention, okay. It is very important convention, okay, to solve any sort of question, right? So passive sign convention means if any passive element is there and current is entering into the passive element, so we will always enter that current with plus sign, right? So suppose this is kind of a resistor, okay, R. So if current is flowing here, so you will say always plus to minus, right? So plus to minus voltage you going to, okay, right? See, the voltage across this is going to be what? Plus to minus, okay, plus to minus. This is very important, right? So in order to apply KVL and all, you need to know the relationship between I and V, okay, across any element, okay, if you want to apply KVL, right? So this is very important. Voltage is nothing but what? The potential difference, okay. And remember that suppose this is A point and this is B point, so always we say that this point is at higher potential compared to this point, okay, always remember. So whenever you will see any circuit, so we have to always consider one reference, ठीक है, एक reference आपको लेना जरूरी रहता है. Many people forget this, right? Whenever they apply KCL, so they forget the reference point. Reference point you never have, you never have to forget, right? So always take, if you are up, okay, so that you can say the A point has higher potential if you compare with the B point, right? In case of analog circuit also, when you talk about BJT, bipolar junction transistor, okay, supply is here, okay. When you come down, the voltage is going to decrease, voltage decreases, right? So in BJT and all the terminals are fixed, right? Everything is fixed. Here what is there, sometimes what happens, these polarity can be changed, okay. Remember what I want to say here is that, देखो, जैसे मान लो this is a BJT, right? Okay, you can say this is a BJT, fine, and this is plus VCC, okay, RC is there, right? And suppose there is a 4 volt, right, and there is a plus to minus 0.7. See, you can never make minus plus here, right? The terminals, these potentials are fixed, you cannot change anything, okay. So suppose you're coming down, if you're coming down, so you should directly, you can write here, this is going to be 3.3, right? You need not to apply KVL over there, right? You can directly say that if you're coming down, right, 4 volt is there, you're coming down, so it will be 3.3 directly, okay. You don't have to think about, oh, KVL has to apply, right? So this is important thing that one has to keep in mind, right? So but in case of this element, okay, suppose this is the element, right, and suppose there is a 4 volt and here you can say 3 volt is there. Someone is going to ask you what is the potential at this point, so you will say that 4 is going down by 3, so 1 volt, okay. But suppose you change the polarity of this terminal, right, so you can say that this is 4 volt, right, and you can say this is minus plus 3 volt. Now what is the potential at this point? So you are coming down, okay, but this is plus minus, you are coming down, right? So you are going to subtract directly this, but this is minus 3 volt, right? So you have to what? You have to add here, okay. This is very important to keep in mind, right? Okay, so what will happen here is that it will be what will happen here? Can someone tell me? 4 minus and 3, you are going down, right? So what will be the voltage at this point? Yes, Anybody can tell me, right? Who have joined here, right? So you should know always, right? Suppose we are at higher potential and the lower node will be having lesser potential. So if no potentials are given, right, so we can consider always the ground as a reference, right, for any circuit you are solving. Yeah, that is very important to keep in mind. Fine, so let's move ahead. This is very important to keep in mind. Now we will talk about any electrical element, right? So any electrical element you talk about, any electrical element. Okay. Suppose I'm talking about any electrical element. So that electrical element should have always two terminals, right? We need always two terminals, right? Any electrical element you talk about, there will be two terminals. Okay. Suppose we talk about this is going to be right. So you can say that any electrical element, it should have how many terminals? It should have always greater than or equal to two terminal, right? Two terminal. Why we are saying greater than or equal to? See, suppose I'm talking about resistor, so it has two terminal, right? This is the resistor, it has two terminal. Suppose I'm talking about inductor, so this has two terminal, one terminal, two terminal, right? Suppose I'm talking about, you can talk about this. How many terminals are there? Three terminals. If you talk about MOSFET here, right? How many terminals are there? Three terminals, right? So any electrical element you talk about, there will be two terminals, okay? And across the terminal, we are going to measure the voltage through the wire, you can say, through the, you can say if you are moving from this point to this, you can say this node to this node, so there will be a current, right? And the voltage across this will be, you can say that voltage V, okay? So we need to understand how we can manage the relationship between V and I. So we need to recall Ohm's law, right? Okay. So that is very important. So these are three terminal devices. Here you see three terminal devices, okay? And these are two terminals. Okay? So any electrical element you talk about, there will be two terminals, okay? Okay, and what is terminal? What is terminal? The terminal is nothing but what the kind of, you can say, where the current can flow, right? Okay, these are the points, you can say, right, where the current can flow. This is very important, okay? So let me take this is one representation of electrical element, right, where the current is going to flow and the voltage is going to be V. Okay, always remember when current is going to flow, right, through the element, so we can write here plus to minus, okay, if examiner hasn't specified the directions, right? But suppose examiner has specified the direction, so you have to choose according to the examiner, right? But the passive sign convention that I will talk about, passive sign convention, passive sign, okay, convention, this will be applicable for passive elements, right? So if current is flowing through any element that is passive element, so what will happen? The current will be always entering from plus to minus, okay? Okay, you should never write like, suppose this is a resistor, so current is entering, so you should never write like this, okay? This is wrong. Okay, we have to follow the passive sign convention, right? But if in the exam they have already specified, you have to follow that. Okay, so suppose this is going to be a kind of black box, you can say black box. This is a black box, you see here. Now how many terminals are there in this case? Can someone tell me how many terminals are there in this case? There are three terminals, right? There are how many terminals? There are three terminals, okay? So you can say you can apply voltage here, you can apply voltage here, you can apply voltage here, right? Okay, plus minus, plus minus. Suppose current is entering like this, okay? Current is coming out, okay? You can say current is entering, right? So this is the three terminal network. So any circuit can have n terminal, right? You can say there can be many terminals, right? N terminals, okay? This is very important. So n terminal element, okay? So there will be n minus 1 independent voltage and currents, right? So suppose there are n terminal, suppose any element is an n terminal element, so how many currents and voltage can be? So you have to say n minus 1 V and I will be there, right? So if you look at this, how many currents and voltage can have this element? Only one current and only one voltage, right? Okay. So please remember these points. And suppose let me take one black box here, and these are the two terminals here. These are the two terminals here, right? Okay. So we call this as two-port network. We call this as two port network, right? If someone is going to ask you how many terminals are there here, so it has two terminal, right? Okay, so here we are going to apply some kind of a source, you can say, okay, some kind of a source. Okay, right now I did not talk about source, so I will not say. So what is port? Port is nothing but pair of terminals, right? So in order to define port, you need how many terminals? Two terminals, right? Port, two terminals. Okay, so these are the very important thing that you have to remember. Moving forward, okay, moving forward, as I told you that electrical circuits are nothing but what? Interconnection of elements, okay, such that there is at least one loop of element, right? One loop is there, okay. So you have to, this is very important. So let me come back to talk about electrical circuit. Right? So it is nothing but what? Interconnection of, okay, interconnection of electrical elements, right? Electrical elements. There is at least one loop of element, you can say, at least one loop, right? At least one loop of elements should be there. Okay, if you are talking about circuit, right? So in case of circuit, there should be at least one loop. अगर मान लो कोई भी network आप design कर रहे हो using electrical circuits, using electrical components, so if there is no loop, you should never say that that is a circuit. Please remember this, okay? So for circuit, there should be some loop, okay? For network, it's okay, like transmission line and all, right? So this is important point that you have to remember, right? So just I'm going to show you, suppose this is going to be one element, this is one element, this is one element, right? Okay. So this is going to be one loop here. You can start from A, B, C, D, right? A, B, C, D. This is going to be a what? There is a loop. And what is this loop? Loop is nothing but closed path consisting of all the elements, you can say, right? So all the elements are there, okay? And if you're joining two elements, you see here, guys, this is one element, this is one element. You're joining with the point here, okay? This point is nothing but node. We call it node here, right? Though I should not explain all these things, everybody knows these points, right? So all the elements is going to be, see, you're starting from here and you're touching all the, you can say, all the elements. That is going to be a loop, right? Or a mesh, sometimes we call it, right? So what we can do here is we can also write like this. Dekho. You see, okay, sometimes in instrumentation or kind of branch, they might ask you how many meshes are there in the circuit, how many loops are there. Okay, these kind of questions they might ask, so you should be able to answer them, right? So you see, there is no element, please remember. Sometimes this kind of a branches are given, right? There is no element, okay? There is no element, okay? So this wire is what? This is ideal. कोई element ही नहीं है, right? Okay, so you can also you can say that this is single node, you can say this is single node. Okay, if there is no element, means single node you can consider, right? And this is going to be a node here, this is going to be a node here, okay, where the, you can say, elements are joining, right? And if someone is asking what is branch, so element itself is a branch. One of the very easy definition of branch I am telling you, element itself is a branch, right? Element itself is a branch, right? First, if any electrical element is there or a component, you can say that is a branch, right? So when two branches join, that is going to be a node, okay? So many branches can join at a point, right? So please remember this thing, okay? Now we will come to why we are talking about node, guys. Node means you see here, suppose this is going to be one element here and this is going to be one element here, right? And these are the elements, you can say, right? Okay, this is going to be a node. Okay. Let me take suppose there is one more element connected and one more element is here, right? So suppose the current is flowing here, I1 is flowing, I2 is flowing, right? I3 is flowing, and one more current I4 is flowing, right? So we can talk about one of the very important law, that is nothing but KCL, right? That is nothing but KCL, okay? See, in this case, remember, we only know we only know what current through the branches, right? Current through the element, you can say. You don't know what is element, what kind of element is there, right? See, whether it is resistor or capacitor or inductor, any kind of element is connected, but you know the current through that element, right? If you know current through that element, okay, in the question, okay, many times question has been asked in the gate examination, you can take up PYQ. So element will be there, and you don't know about the value of the element or what kind of element is that, but you know the current is flowing through that element. So you can always apply KCL, right? If all the currents are known, remember, if all the currents are known through the branch or in all the branches, you can apply KCL. What is KCL? Basically, Kirchhoff's current law, right? And we always choose the node to apply KCL, right? And to apply KCL, only what you need is you need to know the current through each branches, right? Okay. So can somebody tell me here what is going to be C? We can say that here the current is coming, currents are coming, right? And currents are going. So remember that the incoming current, right? Incoming current to the node I'm talking about, sum of incoming current to the node, or you can say outgoing, right, is equal to sum of outgoing current. This is the very basic definition of KCL, you can say. So whenever there is a node, right, so you have to say how many, what are the currents which are coming, what are the currents which are coming, okay? Yeah, what are the current which are coming, okay? Remember, so you just write down like this, sum I1 plus I2 plus I3, right? And what are the current which are moving away, you can say outgoing current, right? So this is I4, simple. So always remember, KCL is nothing but what? KCL is current sensitive, current direction sensitive, you can say. Current direction sensitive, okay? Current direction sensitive. Please remember this. Suppose I say that, let me take one very easy example, right? Suppose there is a current of 5 ampere, right? And this is going to be one element here, right? You can take any sort of element, right? I'm not saying 2 ampere. And someone is going to ask you what is this value, Ix, right? So how can you find this Ix? How can you find this Ix? Okay, so there is a node here, right? There is a node. So you don't need any sort of example. Oh, I mean, you need not to know the what kind of element is connected over there, right? Just apply KCL. KCL का मतलब क्या होता है? KCL is nothing but what? Just you have to apply this. The whatever currents are coming, you just add them. Whatever currents are outgoing from the node, you can say, you just equate them, right? Okay, and sum of incoming, sum of outgoing. Okay, so you see guys, this is coming, okay, so you can say 5, and this current is also coming, so you can say that Ix, okay, simply, and this guy is going, so 2 ampere. So Ix is going to be what? 2 minus 5, which is minus 3 ampere, right? So please remember this technique, okay? Don't complicate your brain, okay? Don't complicate your brain, understand? And while applying KCL, remember, while applying KCL, suppose current directions are not given in your circuit, so what you can do here is you can assume current, okay? Always consider currents which are moving away from the node, outgoing, right? So suppose ऐसा हो सकता है कि सारे currents आपके move कर रहे हैं, जैसे मान लो यहाँ पर ऐसा है situation, ये मान लो we have to apply, suppose any network you take, right? ये मान लो एक network है, T network you can say, and this is the situation, right? Suppose we have to apply KCL at this point, and we don't know the we don't know the currents, so we can take I1 here, I2 here, I3 here, all guys are going away, so simply we say that I1 plus I2 plus I3 is going to be 0. Okay, this is simple KCL, right? This is simple KCL, right? Please remember, KCL कैसे लगाते हैं? KCL means currents direction sensitive, okay? If you're going to choose current like this, okay, understood, and you're going to take some different understanding जो भी आप लोग पढ़ते हो, right? मान लो ऐसा है कि suppose this current, let me take like this, मान लो ऐसा आप करते हो, ठीक है? You have assumed this is fine, right? But make sure that whatever currents are coming, right? Whatever currents are coming, you have to add whatever currents are going away, you have to equate with that, right? So इसको लिखेंगे I1 plus I2. Suppose this is I1, this is I2, and this is I3, right? So it should be written like this. Okay. ठीक है, you should never write I1 plus I2 plus I3. This is wrong. This is wrong. So you always write like this, okay? Whatever currents are incoming to the node, whatever currents are outgoing to the node, right? This is very important to remember, okay? Don't think like that, okay? Whatever currents are leaving, let us take positive currents. Whatever currents are entering, let us take negative. It will confuse you simply, right? I'll always remember KCL means incoming current, sum of incoming current is equal to sum of outgoing current. I'm talking about KCL with respect to node, guys. Okay, so KCL obviously we discuss with respect to node, right? तो ये मेरा अंडरस्टैंडिंग है, कभी गलती नहीं होती है. आई नेवर मेक एनी सॉर्ट ऑफ मिस्टेक व्हाइल अप्लाइंग KCL. अब आपके माइंड में ये डिसीजन होना चाहिए. You should be able to decide when you have to apply KCL and when you have to apply KVL. Only 2 days, Tom B. Only 2 days. Network theory only 2 days. Today, tomorrow, wind up, then next day PYQ, all PYQs, right? All PYQ will be discussed, okay? तो आपका हमेशा ऐसा ही रहेगा. 2 days theory, 1 day questions, ठीक है? 2 days theory बहुत इंपॉर्टेंट है, द वे आई एम गोइंग टू टेल यू, राइट? तो आपको अब ब्रशअप हो रहा है पूरा का पूरा, राइट? ये तो बहुत बेसिक चीजें हैं, एवरीबडी नोज दैट, राइट? फाइन. तो ये KCL की स्टोरी आपको क्लियर है. सो सम ऑफ करंट एंटरिंग, sum of current leaving, ये याद रखना. KCL means sum of current entering is equal to sum of current leaving. That's it. This is KCL. Don't waste your time further, right? ठीक है? And when we apply KCL, there should be a node, right? So node is very important. At node. Fine. Now we will talk about what. So you can also think about KCL, right? Analogies and all. I need not to discuss. Okay. But KCL means we have to apply KCL when there are currents, you know, at the node coming, outgoing, right? Just sum them, equate them, right? That's it. Fine. Now let us talk about Kirchhoff's voltage law. ये सबसे important है, right? KVL. Kirchhoff's voltage law. This is very important. Many people make mistake. Many people. कोई भी उनको पढ़ा दे, mistake करना ही है. What is this? Always keep in mind. KVL is nothing but what? KVL is, you know, polarity sensitive, you know. KVL is nothing but what? Kirchhoff's voltage law. So we have to move around the loop, okay, and we have to take all the voltages. लेकिन उनका साइन क्या लेना है, that matters a lot, right? तो मेरा ये जो स्टेटमेंट है उसको एक्सेप्ट कर लेना कि सपोज देयर इज अ वोल्टेज एलिमेंट लाइक दिस, देयर इज अ एलिमेंट लाइक दिस, देयर इज अ एलिमेंट, देयर इज अ एलिमेंट, ये एलिमेंट, ओके. I hope this makes sense. You can say that this is A, this is B, this is C, this is D. You don't know what are these elements. मुझे I don't care about it, right? See, the moment you know the voltage across any element, don't care about that element, right? ठीक है. If you know, remember, if you know the voltage across that element, don't care about that element. It can be any element, right? But if you don't know the voltage across that element, then you have to determine the voltage across that element, right? Like before you apply, you know, KVL and all. But if you know the voltage around the loop across all the element, don't care about what is that. That you can treat as a black box. तो आप black box ले लो. तो आप बोलोगे कि सपोज आप A से B जा रहे हो, मान लो ये नोड 1 है, नोड 1, नोड 2, नोड 3, नोड 4, राइट? सपोज यू आर गोइंग कमिंग फ्रॉम B to A, सो आप बोल सकते हो ये प्लस टू माइनस V1, राइट? यू कैन से प्लस टू माइनस V1, राइट? And this is plus to minus V2, okay, understood? This is plus to minus V3, okay, and you can say that this is plus to minus V4. Just I have chosen whatever polarity. This is given in the question, right? Now you have to apply KVL. So you can start like this, KVL, okay. So how to apply KVL? Always remember, if you are, suppose you are moving from this point to this point, so if you are taking this sign, right, this sign, if you're taking, like you are writing minus V1, so you have to take first sign only, first sign, first sign, first sign. Minus V1 minus plus V2 plus V3 plus V4 equal to 0. So V1 is what? V2 plus V3 plus V4. ठीक है. Suppose by some people might do like this. This is first case, right? Second case you can do. Suppose you're taking this sign, you know, so you can say that plus V1 minus V2 minus V3 minus V4 equal to 0. Same result you will get, same result. Okay. So always if you are going to choose first element, remember this is very important guys. Okay, ये सबसे बड़ा इंपॉर्टेंट केस है. लेकिन एनालॉग सर्किट में आपके पास सारे टर्मिनल्स फिक्स होते हैं, राइट? इन एनालॉग सर्किट आई एम टॉकिंग अबाउट, लाइक इफ यू टॉक अबाउट बीजेटी, तो अगर आप बीजेटी में देखते हो तो यू नो इफ यू आर कमिंग डाउन यू हैव टू ऑलवेज सब्ट्रैक्ट, इफ यू आर गोइंग अप you have to always add, right? So these things you have to remember. Don't take analog circuit as network theory purely, right? Many people have done, I have seen कि ओ नेटवर्क थ्योरी को, सॉरी एनालॉग सर्किट की कोई भी प्रॉब्लम को एज अ नेटवर्क सॉल्व करते हैं, राइट? वो गलत है, राइट? आपको समझना है कि देखो एक्टिव डिवाइसेस आर डिफरेंट, ये पैसिव है, ठीक है? पैसिव चीजों को आप डील कर रहे हो, जैसे डोंट डील एक्टिव डिवाइसेस है, ओके? क्योंकि वहां पर क्या होता है ना, पोलैरिटी चेंज किया, लाइफ ओवर, आपका बीजेटी रिवर्स बायस में हो जाएगा, आपको पता होगा, मतलब रीजन चेंज हो जाएगा, एक्टिव रीजन से लेके यू नो कट ऑफ रीजन में भी जा सकता है, सैचुरेशन रीजन में जा सकता है, राइट? तो नेवर प्ले विद दैट पोलैरिटी, वो फिक्स है, ठीक है? कि बेस टू एमीटर आपका प्लस टू माइनस ही होगा, ठीक है? नहीं तो रिवर्स किया, लाइफ ओवर, राइट? तो इट विल नॉट बिहेव लाइक एन एम्पलीफायर, ठीक है? तो ये सारी चीजें आपको याद रखना है, ठीक है? ये पैसिव है, यू कैन डू एनीथिंग, राइट? आपको क्या याद रखना है? पहला साइन, इफ यू आर गोइंग टू टेक फर्स्ट साइन, फर्स्ट साइन, फर्स्ट साइन, फर्स्ट साइन, फर्स्ट साइन, राइट? इफ यू आर गोइंग टू टेक सेकंड साइन, चलो एक क्वेश्चन कर लेते हैं फर्स्ट. सपोज यू नो द you know what the potential drop across them, right? You can say voltage drop across them, right? I'm just going to choose some you know, suppose plus to minus, you know, 2 volt, 3 volt, 4 volt, and you don't know what is this Vx, right? Now they are asking what is the value of this Vx, right? So many people might make mistake here, but I'm not going to make mistake. It is my experience. क्या सबसे पहले आपको क्या करना है? You start with here. You can start from anywhere, no problem, right? Loop means what? KVL means you have to collect all the voltage drop around the loop, right? You just move like this, okay? Move. To apply KVL, what is required? To apply KVL, you should know the voltage across each element, right? So we must know the voltage across each element, okay? Each element along with the polarity, right guys? Polarity बहुत important है, many people make mistake. So KCL means what? KCL is a direction sensitive guy and KVL is what? Polarity sensitive, right? So you have to understand, okay? So passive sign convention तो बहुत important है. मान लो आपके एग्जाम में साइन ऑलरेडी गिवन है across any element, यू नो सम वोल्टेज स्पेसिफाइड और स्पेसिफाइड है, ठीक है, पोलैरिटी के साथ, तो आपको उसको चेंज नहीं करना, डोंट डिस्टर्ब इट, ओके? जैसे मैंने बताया, मान लो कोई वायर है, सपोज एनी वायर इज देयर, ओके? सपोज ये मान लो आपके पास एक एलिमेंट है, राइट? एंड यू वांट टू मेजर व्हाट इज द वोल्टेज अक्रॉस दिस एलिमेंट, व्हाट यू विल डू हियर? यू विल अप्लाई सम सॉर्ट ऑफ अ वोल्ट मीटर. क्या अप्लाई करोगे? वोल्ट मीटर अप्लाई करोगे, राइट? बट दिस वोल्ट मीटर शुड हैव हाई रेजिस्टेंस, ओके? हाई रेजिस्टेंस, जिससे कि मेजरमेंट में कोई मतलब आपका सर्किट सेम है, राइट? आपको सिंपली वोल्टेज से मतलब है कि व्हाट इज द वोल्टेज अक्रॉस दैट एलिमेंट. तो ऑलवेज रिमेंबर, जैसे आप फीडबैक एम्पलीफायर पढ़ते हो एनालॉग में, राइट? सो वी ऑलवेज सैंपल सम वोल्टेज, राइट, फ्रॉम द आउटपुट, यू कैन से फ्रॉम द आउटपुट, ओके? एंड वी add it, you can say we add in input or we subtract whatever you do depending on the feedback. तो वो सैंपल कैसे करते हो वोल्टेज? आपको वोल्ट, you have to connect one वोल्ट मीटर, राइट? अब वोल्ट मीटर का जो रेजिस्टेंस होना चाहिए, द वोल्ट मीटर रेजिस्टेंस अक्रॉस दैट शुड बी वेरी हाई, ठीक है? ये बहुत इंपॉर्टेंट है, राइट? तो now you want to apply here, so what you can do here is by KVL. So you start plus 2 volt, right, plus 3 volt plus 4 volt plus Vx equal to 0. Now Vx equal to what? All guys can be added here, right? So 3 plus 2, 5 plus 4, this is minus 9 volt. Answer khatam, ठीक है? You will never make mistake guys, ठीक है? This is very important to keep in mind, okay? तो ये KVL का ट्रिक है, I mean, you can understand the sign and all, right? Let's move ahead. Okay. So what is this? You can say that, what is KVL? KVL is nothing but sum of all the voltage drop around the loop. Okay. Around the loop. Okay. Along with the what? Along with, you have to keep in mind that voltage drop, that voltage drop can be rise or you can say fall. Rise or fall, you can say, right? Why I'm saying rise and fall? See, if you're moving, suppose this is the element here, right? This is the element, this is the element, this is the element, right? Okay. Suppose this is plus to minus V1. So this is at high potential, right? Certainly plus is at high potential. It is at low. So if you're moving like this, so what you're going to do? Fall. The voltage is going to fall, right? And suppose you're moving from minus to plus like this. It is going to rise. This drop, this potential is going to rise. Okay. So आप क्या करोगे? Instead of talking about rise and fall, better क्या करो आप? याद रखो polarity. कि आप पहला पोलैरिटी ले रहे हो तो प्लस V1 प्लस देन प्लस फर्स्ट साइन फर्स्ट साइन फर्स्ट साइन फर्स्ट साइन. सपोज समबडी इज कंफर्टेबल विद सेकंड साइन, तो आप ले लो सेकंड साइन से स्टार्ट कर रहे हो, दूसरे एलिमेंट का भी सेकंड साइन लेना है, थर्ड का भी लेना, फोर्थ का भी लेना, राइट? नेवर मेक मिस्टेक अगर आपको ये राइज एंड फॉल का कॉन्सेप्ट नहीं आता है तो, ठीक है? और आपको राइज का मतलब समझ में आना चाहिए कि नीचे से ऊपर जाओगे तो राइज, ऊपर से नीचे आओगे तो फॉल, खत्म, ठीक है? So I think this is clear. So both KVL is clear, right? KVL is clear. KVL is very, very important equipment that you have to remember, right? Now we will talk about passive sign convention, जो कि बहुत important है. Passive sign convention, right? Passive sign convention. You see any question you can take, right? Any question. These are the basic required, you can say equipments which you need to solve any question. So अभी तो मैं कोई circuit consider ही नहीं किया हूँ, just I'm talking about basics, right? So what is this passive sign convention, guys? Remember, passive sign convention says that, okay, what it says that when current I flowing into the terminal, okay, when current I flowing into the terminal defined as what? Positive for the voltage V. This is very important to remember, ठीक है? तो मान लो आपके पास ये एलिमेंट है, I don't know what kind of element is this. It can be voltage, it can be capacitor, it can be resistor, it can be inductor. मान लो यहाँ से करंट कितनी फ्लो रही है? I. तो जो हमारा पोलैरिटी होना चाहिए वोल्टेज का स्टार्टिंग विथ प्लस, राइट? दिस इज द पैसिव साइन कन्वेंशन, ओके? पैसिव साइन कन्वेंशन. सो सपोज इन द एग्जाम, इन द सर्किट, दे डिड नॉट स्पेसिफाई एनीथिंग, right? मतलब polarity they did not specify. They said directly that find the voltage across a 2 ohm resistor, right? And they did not specify the polarity. तो आप क्या कर सकते हो? Use the passive sign convention. मान लो एग्जाम में they have specified plus to minus or minus to plus, so follow that, guys. Find the current through that and follow that polarity. ठीक है? ऐसा नहीं है कि आप खुद से passive sign convention लगा दो, है ना, और गलत हो जाए, ठीक है? तो कभी कभी ऐसा हो जाता है एग्जाम में, आई हैव सीन. तो ये जो पोलैरिटी का मिस्टेक है, मैनी पीपल डू. इनफैक्ट आई आल्सो हैव बीन डूइंग द सेम. लास्ट ईयर इन 2023 आई डिड द सेम, राइट? एंड आई रिग्रेट. सो आई डोंट वांट यू गाइस टू गेट रिग्रेट, ओके? क्योंकि आप एक मार्क्स अगर आपका कम आता है तो आप पीछे हो जाते हो सीधा, ठीक है? तो आपको याद रखना है. ये इंडिया में बहुत सारे लोगों को प्रॉब्लम है, क्योंकि आप लोग obviously you invest your time on various YouTube channels, right? And nobody talks these things, ठीक है? वो डायरेक्टली कुछ हवाई कुछ बड़े बड़े क्वेश्चंस उठा के, है ना, समझा देंगे तो आपको लगता है बस हो गया, लाइफ इज ओवर, राइट? ठीक है, यही है सब कुछ. नहीं, ये छोटी छोटी बातें. वो एक लाइन आप याद रखना. क्या लाइन? डोंट मिस द फॉरेस्ट, ओके, फॉर द ट्रीज, ठीक है? ये छोटी छोटी बातें तो याद रखो, लेकिन क्वेश्चन करते आना चाहिए प्रॉपर तरीके से, राइट? फाइन. तो पैसिव साइन कन्वेंशन इज वेरी इंपॉर्टेंट. यू कैन राइट डाउन हियर करंट आई फ्लोइंग इनटू द टर्मिनल, या करंट आई फ्लोइंग इनटू द टर्मिनल, ओके, फ्लोइंग इनटू द टर्मिनल. व्हाट टर्मिनल? डिफाइंड एज पॉजिटिव, राइट? positive for the voltage. So if this current is flowing through this terminal, so this terminal should be positive here, right, for a voltage. ये आप याद रखोगे अगर स्टेटमेंट तो लाइफ में कभी भूलोगे नहीं. Okay, when in the interview they might ask what is this passive sign business, right? So you should know these things. Okay, you should always know. Okay, so there will be you can say this is A node and this is B node, and there is a current flowing, right? Current flowing through the terminal. Okay, current always flow through the terminal and voltage will be across the element. Okay, that you have to remember. I hope this makes sense to all. Next point that we have to discuss is what? Suppose let me take here suppose this is a voltage source. Though I did not talk about voltage source, but you should know. Suppose this is voltage source, right? And this is kind of independent voltage source, and you can see that 3 volt is there, right? 3 volt across this. Okay, please remember. Understand? So आप क्या बोलोगे? According to passive sign convention, I is what? Suppose I is flowing through this, right? So you will say that V naught is going to be 3 volt. Suppose you are going to measure across this. Okay, what is V naught? तो आप क्या बोलोगे? If current is flowing like this, remember, if current is flowing like this, you will say V naught. ठीक है, V naught is going to be 3 volt. Suppose current direction is changing, right? Suppose current direction changes. Okay, if current direction is changing, then what you will say? That is very important to remember, right? So it is very important to keep in mind, right? तो आपको क्या याद रखना है कि करंट डायरेक्शन अगर चेंज होता है, देन इफ यू आर गोइंग टू मेजर अक्रॉस दिस, व्हाट विल बी द वोल्टेज, तब भी आपका क्या यहाँ पर रहेगा. आप देखो ये 3 वोल्ट तो चेंज होने वाला नहीं है, राइट? 3 वोल्ट इज नॉट गोइंग टू चेंज, राइट? तो दिस इज वेरी इंपॉर्टेंट. अगर पोलैरिटी यहाँ पर मान लो ऐसी है, ठीक है, आई विल एक्सप्लेन वोल्टेज सोर्स वेरी सून. सपोज दिस इज द पोलैरिटी एंड अगर मान लो यहाँ पर वोल्टेज पूछता है व्हाट इज दिस वोल्टेज, वी नॉट. तो वी नॉट इज गोइंग टू बी व्हाट, -3 वोल्ट, राइट? प्लीज रिमेंबर दिस. ठीक है, so now I'll talk about sources, and first of all I'll talk about, see, there are 2 sources basically. Okay, they are voltage and current, right? These voltage source, they can be independent voltage source or a controlled source also, right? So basically I'm going to focus on independent sources, right? The independent source में they are ideal and practical, right? They are ideal and practical. Okay. Ideal and practical. Why we call it ideal, why we call it practical, that you have to understand. So these sources are nothing but independent sources. Why we call it independent, अभी पता चल जाएगा. Just in a moment you will come to know why we call it independent, right? So yes, so what is this independent business that you have to remember? तो मान लो आपके पास कोई वोल्टेज सोर्स दिया है, दिस इज काइंड ऑफ वोल्टेज सोर्स, राइट? यू कैन से दिस इज अ वोल्टेज सोर्स, राइट? यू कैन से V, this is a voltage source and the voltage across this is V, you can say, and there is a node, you can say, like A to B. ठीक है, तो ये क्या कहता है, what does this voltage says? Voltage source says that it will always maintain the specified voltage between A and B, right? Regardless of the current flowing through it. Whatever current is flowing through this A to B, it says that I'm going to maintain the specified voltage. Whatever voltage you have written over there, like you have connected 4 volt, 5 volt, whatever. It says that I'm 3 volt only. Nothing is going to change, remember, right? So the potential difference between A and B will be always same, irrespective of the current. Okay, so यहाँ पर क्या होगा, current can be anything through this, right? Current is not known, right? So it always maintains what? It always maintains, okay, specified voltage, right? Regardless of what? Regardless of current flowing through this. Okay, remember. So whenever there is any element, suppose this is a voltage source I'm talking about. So if there is a current, there is a voltage. So we always try to do this, I versus V, I versus V. Okay. In analog circuit also you might have seen, we always do IV characteristic. We draw the VTC, voltage transfer characteristic. If we are going to plot output voltage and the input voltage, so there is a IV characteristic, there is a voltage transfer characteristic, right? तो आपके पास कोई एलिमेंट है, टू टर्मिनल डिवाइस है, ओके, सो यू इफ यू हैव गॉट वोल्टेज एंड अ करंट, यू कैन ऑलवेज प्लॉट. So we know that ये ideal voltage source आपका है. Ideal voltage source says that whatever current flows through this, we don't know what is the current flowing through this. It can be very high, whatever. So I'm going to be constant, right? So this voltage is going to be constant always. Remember, ये voltage क्या है? Constant आपका है. This voltage says I'm constant, right? You see, this voltage is constant here, and the current is flowing anything, right? This current can be anything. Please remember that. ठीक है? It is very, very important to remember, right? Okay, so V is equal to V naught, okay, regardless of current. So someone is going to ask you, can you plot this? So the V will be equal to V naught, okay, and the current can be anything. You can say this. So this is nothing but what? V equal to V naught. So what is happening here is you can say I is kept on y-axis. So y-axis is changing. There is a change in y-axis, but there is no change in voltage. So suppose कोई पूछता है what is change in y upon change in x, or you can say that change in current upon change in voltage. This is nothing but a slope. This is nothing but a slope, right? And here the slope is infinity. Okay, here the slope is infinity. So I versus V, I upon V is a conductance, right? So if you take the ratio of that, so यहाँ क्या आ जाएगा? Resistance. So if someone is going to ask you what is the resistance of internal resistance of ideal voltage source, तो आप क्या बोलोगे? जीरो सर. क्यों? क्यों? Resistance is basically what? Resistance is nothing but, in this case, from IV characteristic 1 by slope, and that is 1 by infinity, which is 0. and 0 को हम लोग कैसे शो करते हैं? शॉर्ट सर्किट से हमेशा, राइट? शॉर्ट सर्किट से. So if this is a voltage source plus minus, so there is no resistance at all. So we call it, this is the ideal voltage source, 3 volt. ठीक है? Or you can say if this is a voltage source, right? Suppose this is 2 volt. ये क्या नेगेटिव है? When you will draw the IV characteristic, I versus V characteristic, you can say you are measuring some sort of a voltage V. Okay, you can say. तो ये कितना रहेगा? यहाँ रहेगा -2 volt, right? ये. Okay. Understood. So always remember, sometimes what happens now, suppose circuit is given, this is a circuit, right? Kind of circuit, okay, and they always give this kind of a characteristic in your exam. ऐसे question दे देते हैं, right? ऐसे I versus V, right? और बोल देता है 0.7 volt, ठीक है? So ये I versus V में resistance क्या है? Suppose you have applied positive voltage across certain device. I'm not talking about any device, guys. Just remember, हमेशा याद रखना, सर्किट के साथ आजकल IV कैरेक्टरिस्टिक दे देता है, राइट, एग्जाम में. तो आपको क्या करना है, जब भी ये बिल्कुल हॉरिजॉन्टल इस तरह रहेगा, वर्टिकल मींस रेजिस्टेंस इज गोना बी 0. रिमेंबर, ऐसे वर्टिकल, राइट? इसको हम लोग पीस वाइज लीनियर बोलते हैं. पीस, देयर आर 2 पीसेस, यू सी, देयर आर 2 पीसेस. एक पीस ये हो जाता है, दिस इज 1 पीस, दिस इज 1 पीस, राइट? इसको हम लोग बोलते हैं पीस वाइज कॉन्टिन्यूअस. दीज आर लीनियर्स, ओके, लीनियर, पीस वाइज लीनियर, पीस वाइज लीनियर. एक तो लीनियर क्या होता है, विच पासेस थ्रू ओरिजिन, राइट? और ये क्या है? ये पीस वाइज लीनियर इसको बोलते हैं. क्या बोलते हैं? पीस वाइज लीनियर, ठीक है? तो जब भी I वर्सेस V का ग्राफ आपको दिया है क्वेश्चन में, एंड इफ इट इज लाइक दिस, ओके, लाइक यू कैन से काइंड ऑफ वर्टिकल, ओके, सो यू कैन से दैट यस, रेजिस्टेंस इज गोना बी 0. क्यों? क्योंकि स्लोप इसका कितना है? द स्लोप दिस गाय हैज गॉट, स्लोप is infinite slope. And how to find slope, guys? Always remember, slope क्या होता है? Slope is nothing but up upon across, right? You go up, how much you are going up and how much you are going across. You're not going across anything, right? Because this guy is constant here, right? तो आप बोलोगे up तो आप चले गए, but across 0 है, तो ये infinity slope. And if someone is going to ask you what is the slope of this guy, ये प्योर हॉरिजॉन्टल है, राइट? तो स्लोप इज 0. हॉरिजॉन्टल स्लोप 0, वर्टिकल स्लोप इज इनफाइनाइट. ओके, so depending upon that you can say, yeah, this guy has got infinite resistance, this guy has got, okay, if I talk about resistance, okay, and infinite resistance means what? Open circuit. Infinite resistance means open circuit. Please remember this, ठीक है? So ideal voltage source is nothing but what? The voltage which will always maintain specified voltage across that, okay, irrespective of current. तो आप बोल भी सकते हो कि कोई voltage source है, so we don't know the current is unknown, right? The current can be anything, right? Current can be anything. ये आइडियल स्टोरी है आइडियल वोल्टेज सोर्स की. इफ आई टॉक अबाउट करंट सोर्स, तो करंट सोर्स आल्सो सेज द सेम, राइट? सपोज दिस इज अ करंट सोर्स. So if this is a current source, you can say 2 ampere. So 2 ampere current source is going to be, this is ideal current source, right? Okay. So whatever voltage you apply, right? This, or you can say this is a load here, RL, and you change this, okay, you keep changing this load, right? Okay, you keep changing this load, okay. So this voltage is going to be changing, right? This voltage will vary, but this current is going to be constant, right? ये constant current है, constant, okay. Or you can say it maintains always its terminal current, right? It always maintains its terminal current, right? Terminal current, okay. Please remember, so these are ideal stories, right? So if someone is going to ask you, can you plot the IV characteristic of that? Yes sir, I and V. तो यहाँ वोल्टेज चेंज हो रहा है, वोल्टेज विल गो लाइक दिस, वोल्टेज चेंजिंग यू कैन से, राइट? But current says I am constant here, guys. This is 2 ampere only, right? Now you can find the slope of this. Slope is 0. Obviously slope is 0, मैंने बता दिया है. अगर ऐसा होगा, slope is 0. If line is parallel to x-axis, guys, slope is going to be 0. If line is parallel to y-axis, slope is infinite, okay? And I versus V अगर है, I versus V, मतलब I is kept on y-axis and the V is kept on x-axis, right? So how to measure the current resistance? You have to take the reciprocal of slope. मतलब एग्जाम में आपको ये भी देखना है कि what kind of characteristic is given. Suppose they have said voltage versus I, so directly you can find the resistance from the plot, right? But sometimes what they do is all the time they always give, right? I versus V. So आपको resistance निकालना है, so you have to take the reciprocal of that, right? So यहाँ slope 0, here slope 0. How slope 0? Slope is equal to, see, as I said, the slope is nothing but up upon across. तो आप कितना जाएंगे? You see, up. Okay, you're going up. This is basically what? It is not changing, right? It is not changing, okay? But you see, guys, this is a across, like you are changing lot, right? No change upon change. कितना आ जाएगा ये? 0. Slope is 0, guys, right? तो resistance कितना हो जाएगा? Resistance, which is infinity, and this infinity is nothing but open circuit, you can say. These are the extreme cases. These are what? Extreme cases, ठीक है? तो आइडियल वोल्टेज सोर्स, आइडियल करंट, आइडियल वोल्टेज सोर्स, इंटरनल रेजिस्टेंस 0. क्यों 0? IV कैरेक्टरिस्टिक से आप देख सकते हो. वोल्टेज सोर्स सेज दैट आई एम नॉट गोइंग टू चेंज माय वोल्टेज, टर्मिनल वोल्टेज, राइट? आप कोई भी करंट फ्लो करवाओ, आई एम नॉट गोइंग टू चेंज. Ideal current source means I'm not going to change my terminal current. Whatever load you change, apply, okay, whatever, like you keep changing the load, आप resistance change करते रहो, right? आपका जो voltage है वो change होगा, क्योंकि you know current times the resistance, right? Going to be a voltage drop, वो ohms law से आता है, ठीक है? ये सब याद रखना, these are very important thing, ठीक है? So current is flowing, you can say from, you can take notes and you can talk about that, ठीक है? This is very important to keep in mind. So suppose any circuit is given, some circuit you take, any circuit, ठीक है? Suppose this is a kind of circuit, some circuit you take, and you take connect here one voltage source like this, ठीक है? So this current you cannot change ever in your life, right? Suppose this current is nothing but 2 ampere current, you can't change, okay? This is the constant current, you can say, right? Okay, so this is nothing but ideal current, okay? This is nothing but ideal current, okay? I hope this makes sense. Now we will talk about resistor, guys. Okay, resistor, ये quick revision है, अभी बहुत सारी चीजें हैं. We will combine these voltage source, ideal current source, right? Okay, voltage and ideal current source we will combine with the help of series and parallel, right? बहुत सारी चीजें करना है, राइट? तो वी हैव टू फिनिश इंटायर नेटवर्क इन 2 days, राइट? तो या तो आई होप अभी तक आपको समझ में आया शॉर्ट सर्किट, ओपन सर्किट क्या कैसा है, राइट? अब बात करते हैं रजिस्टर की। देखो रजिस्टर एक कैसा एलिमेंट है आपका, टू टर्मिनल डिवाइस ही है, आपको पहले याद रखना है। रजिस्टर इज अ टू टर्मिनल डिवाइस, you see this is the register, we call it, okay? It is a two terminal device. So voltage, suppose current is flowing like this, so voltage will be across this. What is this voltage? From the Ohm's law, V equal to IR, ये ठीक है? So resistor is going to follow the Ohm's law, always keep in mind. What is the value of the resistance? You can say V by I, always do, ठीक है? V by I versus V अगर characteristic given है, so you can always take the ratio, you can say reciprocal of the slope is going to resistance, right? So इसका यूनिट क्या होता है गाइस? वोल्टेज अपॉन एम्पियर विच इज ओम, ओके, आफ्टर द ओम्स, ओके? तो वोल्टेज अक्रॉस अ रजिस्टर इज ऑलवेज प्रोपोर्शनल टू व्हाट द करंट थ्रू इट। ये बहुत इंपॉर्टेंट है, राइट? तो व्हाट ओम्स लॉ सेज दैट वोल्टेज अक्रॉस द रजिस्टर, you can say resistance, is proportional to what? Current flowing through it, okay, flowing through it, ठीक है? जितना करंट फ्लो होगा उतना ही वोल्टेज होगा, राइट? प्लीज रिमेंबर दिस, ओके? दैट इज वेरी इंपॉर्टेंट, ठीक है? These are basic things that you have to keep in mind. So this resistance you can say is nothing but a proportionality constant, okay? This resistance according to the Ohm's law is going to be proportionality constant, okay, constant, ठीक है? ये सब आप याद रखना, बेसिक चीजें हैं, राइट? आई एम जस्ट एक्सप्लेनिंग क्विकली, आई एम नॉट गोना स्पेंड मोर टाइम। तो V इक्वल टू आई आर एज वी नो, ठीक है? V इक्वल टू आई आर, then what you can say here, I equal to V by R, and this is only applicable guys here in case of resistor. I am telling you, right? These equations are only applicable in case of resistor. You can say 1 by R is nothing but conductance, remember, okay? Or you can say also that I by V is going to be conductance, right? Conductance, okay? Conductance. But in case of analog circuit, when you talk about amplifiers and all, so there we call it transconductance. Transconductance का मतलब क्या होता है? Transconductance means the current is from output and your denominator is going to be from input, right? तो अगर मान लो output and input are going to give you the kind of conductance, if you take the ratio of output current upon input current, input voltage, that will be transconductance, right? But in this case here, I upon V, we don't know whether these are input current or output current. You can say these currents are specified in single terminal. मैंने आपको बताया था if there are two terminals, so how many currents and voltage can be there? One voltage, one current. कैसे? ये याद रखना है। N terminal, so how many currents can be? N minus 1 current and voltage. आप देख भी सकते हो, अगर एक रेजिस्टेंस है तो केवल एक ही करंट होगा, एक ही वोल्टेज होगा, राइट? यू कांट हैव मेनी करंट्स, ओके? याद रखना ये। तो कंडक्टेंस ऑफ द रेजिस्टेंस, ओके, व्हाट इज द यूनिट ऑफ दैट गाय? दिस इज नथिंग बट सीमेन, सीमेन, ओके? रिमेंबर, so one resistor means what? One ohm resistor means, you can say 1 ohm resistance, okay? Understood? 1 ohm resistance is equivalent to what? You can say 1 Siemens. 1 ohm resistance is nothing but 1 Siemens. You can say 1 ohm resistance is nothing but 1 Siemens. ठीक है? मान लो ऐसा दिया है कि 2 ohm resistor is nothing but what? 0.5 Siemens. ठीक है? I hope this makes sense. 0.33. Okay? You see guys, this is how you can convert. Sometimes we need to convert it, right? From resistor to okay. Now the question is, how do we measure the resistance? Okay, I have been solving many doubts across various platforms, so I got to see that many people have a lot of confusion how to measure the resistance, of any shape or size. Any kind of conductor will be given to you and you have to measure, right? Suppose this is a kind of conductor, suppose, okay, ये आपको कंडक्टर दिया हुआ है, मान लो any shape, right? you can say. So this is going to be your area, you can say cross sectional area. This is going to be a length of the conductor, right? Okay, conductor. So you can say that simply this is A and this is B, right? So what is this, how we define the resistance? Remember, the resistance can be find out. This is nothing but a resistivity, guys, property of a material. The resistivity, right? Rho is nothing but length upon length of the conductor, you can say, or upon area. So this is the basic formula that you have to remember always, right? Okay, what rho is the resistivity times length upon area. अब यहाँ पर क्वेश्चन क्या क्या बनेगा, देखो मान लो आप इसको आप स्ट्रेच करते हो, इफ यू आर स्ट्रेचिंग इट, राइट? सो व्हाट विल हैपन, देखो इसका वॉल्यूम फिक्स है. कैन समबडी टेल मी व्हाट विल बी द वॉल्यूम ऑफ दिस क्रॉस सेक्शन? इसका वॉल्यूम क्या है आपको पता होना चाहिए. वॉल्यूम इज गोइंग टू बी व्हाट? वॉल्यूम इज A into L, right? Area times the length is going to be a volume. Volume का मतलब क्या होता है? There should be three length, okay? Product of three length is going to be a volume, right? So volume अगर इसका निकालना है तो length is there और cross section area, that is going to be a volume. Now, if you are stretching it by some means, so what will happen? What will happen? So if you are stretching it, it means that your length is gonna increase, right? If your length is increasing, okay, so your area should also get scaled. Otherwise what will happen? Volume will change, right? Okay, volume should be always same. This is very very important, keep in mind guys. ठीक है, आप कुछ भी करो इसका, okay, volume should be always same, right? Understood? So your resistance can vary, no problem, but you have to always say that yes, if length is changing, so your area is also changing, right? So accordingly you can say that volume is going to be constant. Okay? तो यहाँ से क्वेश्चंस आपसे आ जाते हैं इलेक्ट्रिकल इंजीनियरिंग में मोस्टली, राइट? सो दिस इज वेरी इंपॉर्टेंट टू कीप इन माइंड. So any shape you take, resistivity you should know, length upon area, that gives you the resistance, right? Fine. So this is very very important. So if I talk about IV characteristic, देखो मान लो ये आपके पास resistance है R and the current is flowing I, okay, the voltage across this is going to be V. So this is nothing but V equal to IR. Okay, so you can say that this follows kind of a straight line. Okay, this is I, this is V. So you can say here you just pass it through this, right? Okay, okay, V equal to IR, you can say. So we are keeping at you can say here, right? And I is this. So what is this slope, guys? Is it resistance? Anybody? I upon V is not a resistance, guys. This is a slope. But we will call it what? We are going to say that it is conductance 1 by R. Okay? I versus V will always offer the conductance. It will not offer the resistance, guys. This is very very important to keep in mind. Many people get confused. I versus V दिया है. जब भी क्वेश्चन आएगा याद रखना. Nowadays what they do is they give you the circuit, they give you the characteristic. आप उसको अच्छे से देखो, right? You can solve the question. ठीक है, बहुत अच्छे से देखोगे आपका क्वेश्चन आ जाए. डरना नहीं है, ठीक है? सर्किट के साथ कैरेक्टरिस्टिक दिया है, या दे सकता है, क्यों नहीं देगा? क्योंकि देयर इज अ एलिमेंट, यू नो, देयर इज अ रिलेशनशिप बिटवीन करंट एंड वोल्टेज. सर्टेनली दे कैन प्लॉट इट, राइट? मैथमेटिक्स आप क्यों पढ़ते हो, राइट? आपको ये समझना है. ओके, तो ये जो स्लोप होता है I वर्सेस V का, that is going to give you the conductance and the reciprocal of that guy is going to be resistance. ये आप बार बार याद रखो. And this resistance, it should be what? This resistance should be always greater than 0, right? Okay, this guy should be always positive here. तभी आपको ऐसा straight line आएगा where the slope is increasing, you can say, right? Okay, I hope this makes sense, right? अगर मान लो negative resistance है तो ये फिर ऐसा हो जाएगा, ठीक है? I versus भी negative. There are negative resistance also, ठीक है? ऐसा नहीं है negative resistance नहीं आ सकता. Straight line passing through the origin, इसका मतलब क्या है? Your element is going to be what? In future you will come to know that these elements are linear element, right? अगर कोई element linear है, ठीक है, तो आप बोलोगे कि I hope this makes sense, right? Okay, so I will talk about linearity and all in future. Just I am giving you the brief idea about resistance. Okay, आपको ये सब याद रखना है, ठीक? So now we will talk about capacitor. How do we define capacitor, right? Capacitor, देखो, capacitor plays an important role. For electronics people, MOS capacitor you study, right? Metal oxide semiconductor capacitor. Okay, many people think that, oh, it's a very tough concept. नहीं, आपको basic capacitor का concept नहीं clear है पहले, right? In case of, this kind of a capacitor, if I'm going to draw the symbol of that, ये आपका capacitor होता है, ठीक है? And this capacitor is also a two terminal device. मैंने आपको क्या बताया, अगर कोई इलेक्ट्रिकल एलिमेंट है तो दो टर्मिनल होना फिक्स है. अगर दो टर्मिनल है तो कितने करंट और वोल्टेज होंगे, वन करंट वन वोल्टेज, वन करंट वन वोल्टेज. टू पोर्ट नेटवर्क में आप याद रखो, टू पोर्ट नेटवर्क में हाउ मेनी टर्मिनल्स आर देयर, देयर आर टू टर्मिनल्स, राइट? टू टर्मिनल्स आर देयर, ठीक है? तो कितने वोल्टेज होते हैं, एक वोल्टेज एक करंट. अब जहां फोर टर्मिनल्स रहेंगे, फोर टर्मिनल मींस यू कैन थिंक अबाउट इट, राइट? ओके, आई होप दिस मेक सेंस. तो आपको ऐसे समझना है, ठीक है? तो you see, this is the capacitance here, right? See, and we always say that suppose current is flowing like this, the voltage is going to be V, right? Voltage is going to be V. Now what is the relation between these V, I and C? ठीक है, ये आपको समझना है. Always remember this current will be shown with the help of an arrow, right? And voltage will be across. इसका जो सिंपल सा रिलेशन होता है, I equal to C dVc by dt, ये आपको याद रखना है. I equal to C dVc by dt. I equal to what? C dVc by dt. अब इसका डेरिवेशन भी आप कर सकते हो, you guys can derive it, okay? But अभी डेरिवेशन की जरूरत नहीं है. I equal to C dVc by dt आप याद रखो, ठीक है? I equal to C dVc by dt. ये dV by dt क्या होता है? This is the rate, you can say initial rate, okay? V dV by dt is equal to I by C, right? Okay, so there, suppose we have got two plates. आप ऐसा बोल सकते हो, there are two plates, okay? ये टू प्लेट्स हैं, ठीक है? These two plates, you can say these are the conductor, basically conductor. These are metal plates, okay? They are conductors and they are separated by d distance. Okay, they are separated by d distance, okay? And this plate has got plus q, you can say, and this plate has got minus q charge, ठीक है? ये प्रॉपर्टी होती है मेटल की, राइट? कि अगर एक उसमें पॉजिटिव चार्ज है, दूसरे में नेगेटिव चार्ज होगा, राइट? ये आपको समझना है, ठीक है? अगर आप वोल्टेज अप्लाई करते हो इसके अक्रॉस, तो गोइंग टू अप्लाई द वोल्टेज अक्रॉस दिस, वोल्टेज अक्रॉस दिस. दिस इज हाउ वी हैव टू वी शो दैट, राइट? तो करंट कैसे फ्लो होगा? करंट इज फ्लोइंग लाइक दिस, I. So these are the two plates, okay? We call it parallel plate capacitor, right? Okay. ये हमेशा याद रखना. तो ये इसमें कितना चार्ज होता है, माइनस क्यू, इसमें कितना चार्ज होता है, प्लस क्यू, राइट? प्लीज रिमेंबर दिस, प्लस माइनस, ओके? तो how we can write this q can be written as C times V, ओके? जितना आप वोल्टेज लगा रहे हो उतना चार्ज यहाँ पर रहेगा, क्योंकि जितना चार्ज है उतना वोल्टेज, राइट? तो q will be always proportional to V, q is proportional to V, always remember this, ठीक है? तो यहाँ से आकर आप बोलोगे q equal to CV. This capacitor again is going to be what? The proportionality constant, right? और अगर आप यहाँ पर डिपेंडिंग अपॉन फिजिकल डायमेंशन से डिफाइन करते हो कैपेसिटर, तो C is going to be equal to epsilon, okay, area upon distance. ये डेफिनेशन होती है पैरेलल प्लेट कैपेसिटर, ठीक? तो एरिया क्या यहाँ पर है, देखो, सपोज एरिया इज A, तो C is going to be epsilon A by D below. So this is very important. So in case of parallel plate capacitor, what is there, guys? Two plates are there, which are metal plates, you can say. Top plate has got plus charge, नीचे वाला minus charge, right? आपको ये याद रखना है, क्योंकि फ्यूचर में आएगा, क्वेश्चंस बहुत सारे आते हैं, and many people have no idea about what is this capacitor business, right? तो एक कैपेसिटर तो आप डिपेंडिंग अपॉन देयर फिजिकल डायमेंशंस आप डिफाइन करते हो, जो भी एरिया, डिस्टेंस, ओके, हाउ मच they are separated. Now these capacitor can vary also, right? Depending upon what dielectric you are going to insert, वो सब आप इलेक्ट्रोमैग्नेटिक में पढ़ते हो, राइट? और आप जब भी मार्केट में कैपेसिटर परचेज करने जाते हो, whenever you go to market and buy the capacitor, so they always specify their values, right? कि capacitor can be of 1 microfarad, 2 microfarad, whatever, 100 microfarad, okay, picofarad, femtofarad, right? These are the units. And they also specify one voltage over there, like 100 volt, 2 volt, 5 volt, 10 volt. What is that voltage? That voltage is known as breakdown voltage, guys. कि this much voltage your capacitor can withstand, okay? अगर आप उससे ज्यादा voltage apply करोगे तो फिर your capacitor will will be gone, right? It will be broken. Okay, so breakdown voltage is very important. So आप जब भी देखोगे capacitor, you can take a look कि there will be one voltage along with the value of the capacitance, right? तो ये सब आपको याद रखना चाहिए, ठीक है? So this is very important. Okay, so here since we know that what is this current business, तो current आपको पता है current क्या होता है? How we define current? Current is nothing but rate of flow of charge, that is dq by dt, right? Now you know that what is this charge from the capacitor, you can say C times V, so you can put here I equal to dq by dt. Okay, in place of q you can replace this C times V. This C is constant, so you can take outside, right? Now it is proved, right? So this is a current which will flow through the capacitance. अब ये कैपेसिटर आपके इंडक्टर में लगा है, ये कैपेसिटर आपके पैसिव सर्किट कहीं भी लगा है, हमेशा याद रखना कि सेम करंट विल फ्लो, I equal to C dVc by dt. अब आपको whenever you look at the capacitor anywhere, whether it is op amp circuit, जब आप डिजाइन करते हो op amp, right? अगर डिफरेंशिएटर है, what current is going to flow, तो आपको हमेशा याद रखना है C dVc by dt. वहां पर कंफ्यूजन नहीं कह रहे सर लाप्लास लगा देते हैं, टाइम वेस्ट करते हैं अपना, राइट? बहुत सारे लोग ऐसे हैं कि सर लाप्लास लगा दिया, आंसर नो. ऑलवेज ट्राई टू मैनेज द टाइम डोमेन एनालिसिस, राइट? जितना मजा टाइम डोमेन एनालिसिस करने में है उतना लैप्लास में नहीं है, राइट? लैप्लास is okay when the number of you can say when you are dealing with higher order differential equations, right? लेकिन अगर मान लो फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन है, फर्स्ट ऑर्डर सर्किट है, राइट? ओके, सिंगल टाइम कांस्टेंट सर्किट यू कैन से, तो वहां पर लैप्लास की जरूरत ही नहीं है. ओके, आपको समझना चाहिए कि डी सिंगल ऑर्डर का मतलब क्या है. सिंगल टाइम कांस्टेंट इज देयर, राइट? यू कैन से आरसी सर्किट इज देयर, यू प्ले विद द विद द टाइमिंग एनालिसिस, राइट? तो आपको ये इक्वेशंस पता होनी चाहिए. C dVc by dt, I equal to what? C dVc by dt, right? This is the current which will flow through the capacitor, right? Okay. तो आपको मैंने ये सब बता दिया है. This C is going to be a constant, okay? And your parallel plate capacitor, how can you measure if you know the area? You can say dielectric constant, right? Epsilon, that is a permittivity, okay? Please remember, okay? Those things we cover in electromagnetic in detail, capacitors, okay? I hope this makes sense. So let me define this. So here we have got here I equal to what? I equal to IC equal to C dVc by dt, right? This is this voltage should be time varying voltage here, right? It should not be constant, otherwise the current will be zero. Okay, so you can say that suppose your voltage is increasing, okay? You can say rate is there 1 volt per second, okay? So your capacitor is 1, okay? Suppose dV by dt is given as 1 volt per second, right? That is initial rate, you can say, and your C is given as 1 microfarad, right? How much current you can expect here, right? So current will be basically equal to 1 voltage per second into 1 microfarad, which will give you what? You can say that 1 microampere current is flowing, right? 1 microampere current, okay? So this is very, very important to keep in mind, right? So whenever there is a circuit connected, whenever there is a capacitor and the resistance, you have to always see that, yeah, what current is flowing through the capacitor. When that current will flow through the capacitor, your capacitor will charge, right? That is very, very important, okay? So this is the basic math that we have done, right? If the current is finite, remember this is very, very important. This is very, very important. ये आपको कैपेसिटर से रिलेटेड important to remember for your exam, और आगे के जो भी हम लोग सर्किट करेंगे. देखो, अगर मान लो if current flowing through, okay, if current is finite, you can say, right? If current flowing through the capacitor is finite, okay, or you can say current is finite, so voltage across the capacitor cannot change abruptly, okay? If the current flowing through the capacitor is finite, then voltage across the capacitor cannot change abruptly, एब्रप्टली मीन्स व्हाट, मतलब मान लो वोल्टेज अक्रॉस कैपेसिटर 0 है तो डायरेक्टली वो 5 वोल्ट नहीं हो जाएगा, ठीक है। If the current flowing through the capacitor is suppose 5 ampere it is flowing, okay, suppose 5 ampere is flowing, okay, what you can say that voltage across that capacitor is not going to change suddenly, right? ऐसा नहीं है। अगर मान लो infinite current is flowing, infinite current कब flow होगा, जब मान लो current is in the form of impulse, you can say, right? Because at t equal to 0 if you have got an impulse, I think electrical वाले जितने भी हैं, many people who are from electrical EC instrumentation, they know what is impulse function, what is impulse signal, right? Impulse function has got infinite amplitude at t equal to 0. Area under the impulse is 1. But if you talk about infinite amplitude, right? So at t equal to 0, infinite force is there, right? So if there is an infinite current flowing through the capacitor, so आपका capacitor तुरंत charge हो जाएगा. Immediately it will charge, right? But suppose finite current is flowing, so it will charge what? Gradually, not directly कि abruptly charge हो गया. तो आपका जो change in voltage होगा, that will be what? There will not be any sort of change. ये आप याद रखना. This will be very useful when I will talk about when I will talk about what, the RC circuits, right? ठीक है. I hope this makes sense, right? So suppose we have got I equal to C dVc by dt, right? C dVc by dt, okay? The voltage across the capacitor, okay? Understood. So what is this voltage then? Voltage can be found out one by what we are considering here is that my capacitor is not charged. Capacitor is not charged, right, initially. Okay, this capacitor is not charged. There is no charge at all in the capacitor, right? So you can find the voltage directly. The voltage equation is going to be what? This I dt. So this is only applicable when there is no charge. But you have to keep in mind that this will be from minus infinity to, you can say, right? So you can also write this as 1 by c integration 0 to t d I dt, since there is no charge, right? Now if there is a charge, suppose there is a charge associated with that, okay, understood. So suppose you can say this is a current here, right? I, okay, versus t, current is given, okay, and you can say this is going to be a current, you can say t1 to t2, okay, and this is the area under the current, right? Integration means area, okay, integration means area. So you can say that this is t0 to t1, you are integrating this. So your voltage is going to be what? Your voltage will be 1 by c t0 to t1, right? I dt plus initial voltage vt0, right? Yes. Okay, I think this is clear. Okay, so I think this is clear, right? So ये याद रखना कि when there is an initial voltage, you have to add it here, right? Initial voltage, or you can say initial charge is present. So Q equal to CV, you know, right? So you can find the, from initial charge, you can find the initial voltage as well, right? Okay, sometimes what they do is they might specify the initial charge, okay? ये सारी चीजें आपको पता होना चाहिए, ठीक है? तो area under the curve means what? They will give you the current, kind of current versus time curve, right? And you have to find the voltage. You just find the area, okay? Integrate, understand? So this is very, very important to keep in mind. Understood? This is very, very important to keep in mind, okay? So when there is a current and it is going to charge the capacitor. So when capacitor is going to charge, guys, when current is going to flow. Okay, if the current is finite, your voltage cannot change immediately, right? Matlab, suppose voltage is 0, right, across the capacitor, and the current is started flowing. So you can't say that the voltage will be 12 volt directly. No, okay, the voltage will be 0 only initially, right? That you have to always accept. Okay. So now what we will do here is we have discussed about resistor, capacitor, and so on and so forth. Now we will conduct tomorrow's session, right? Because tomorrow is going to be Sunday, right? So I will be, free only. So I am going to talk tomorrow, okay? And I will continue from the inductor business, right? Inductor. आपको कल हम इंडक्टर बताएंगे और फिर क्विकली वी विल फिनिश ऑल दिस, once the basic is over, everything is going to be easy, right? So today's session is just an introduction, you can say, kind of brush up, okay? So आपको थोड़ा थोड़ा याद होना चाहिए कैसे करना है, right? अब आप you take any question. Right now you can't take any question because I just explained KCL, KVL, but I did not talk about nodal analysis. What is the meaning of nodal analysis, mesh analysis? So from this session you can't solve any question, right? मतलब basic solve कर सकते हो, but अभी भी बहुत सारी चीजें discuss करना बाकी है, right? So we have to talk about inductor, okay? And then and in case of inductor also you have to remember that all of a sudden current cannot change, you know, if the voltage across the inductor is finite, right? अगर voltage across the inductor is infinite, then current can change immediately, right? तो आपको समझना है ये important cases, right, when your capacitor can change voltage abruptly, right? क्योंकि गेट में ऐसे क्वेश्चंस आ जाते हैं, राइट? सो मैनी पीपल लाइक, नो, सपोज देयर इज अ कैपेसिटर, राइट? लेट मी कनेक्ट वन कैपेसिटर हियर. मान लो ऐसा कैपेसिटर है, दिस इज वन कैपेसिटर, दिस इज चार्ज विद 2 वोल्ट, यू कैन से, राइट? And there is a switch, you can say, and this switch is closing at t equal to 0. Now they are asking what is the voltage across this guy, this capacitor, right? So once this switch is closed here, right, once this switch is closed, the voltage across this capacitor will be 0 only, right? Okay, then violation of KVL will happen, okay? So we don't want violation of KVL, guys, okay? We don't want violation of KVL, okay? So you have to flow here, you have to flow impulse current, yeah? अब आपको क्या लगता है, वायलेशन ऑफ केवीएल इज अलाउड? नो 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 नो, रिमेंबर, राइट? तो ऑप्शन में इंपल्स करंट दिया तो आप चूज कर लो, डोंट थिंक अबाउट एनीथिंग, राइट? व्हाई? बिकॉज द केवीएल इज गोना गेट वायलेटेड इफ यू थिंक दैट कि ओके until the infinite current flows I'm not gonna change, right? You have to make here the current is gonna flow infinite, okay? Like IT should be delta t so that it will be okay, otherwise KVL get violated, okay? क्योंकि अभी हम समझाएंगे कि दो वोल्टेज सोर्स ऑफ अ डिफरेंट वैल्यू यू कांट कनेक्ट इन पैरेलल, राइट? वो सारी चीजें आपको याद रखना है, यू हैव टू टेक केयर ऑफ दोस थिंग्स, ठीक है? तो इंडक्टर से वी विल टॉक अबाउट इंडक्टर्स, ओके? एंड देन वी विल टॉक अबाउट म्यूचुअल इंडक्टर, राइट? क्योंकि इंडक्टर इज फाइन बट म्यूचुअल इंडक्टर में बहुत सारे लोगों को डाउट है, सेल्फ इंडक्टेंस, म्यूचुअल इंडक्टेंस, राइट? एंड देन वी विल टॉक अबाउट लीनियरिटी, गाइस, राइट? तो व्हाट इज द मीनिंग ऑफ लीनियरिटी, है ना? फिर आपको स्ट्रैटेजी बहुत सारी बताएंगे. तो कल का सेशन यू माइट एक्सपेक्ट यू नो मोर देन 2 आवर्स, आल्सो मोर देन 2-3 आवर्स, राइट? एंड आई विल अनाउंस द टाइमिंग वेरी सून, गाइस. थैंक यू सो मच फॉर टुडे. आई होप यू माइट हैव एंजॉयड सम ऑफ द बेसिक थिंग, ठीक है? तो कल हम लोग और अच्छा कॉन्सेप्ट देंगे. अभी तो मेरा टेक्निक आपको मिला ही नहीं है बिकॉज ऑलरेडी यू नो दीज थिंग्स, राइट? तो कल आपको मेरा टेक्निक मिलेगा. आई थिंक ये एक ब्रशअप कॉन्सेप्ट था. आप कोई भी प्रॉब्लम देखोगे, नाउ यू विल बी एबल टू रियलाइज कि सर्किट दिया है, उसके साथ आईवी कैरेक्टरिस्टिक दिया है, एंड यू कैन डू एनीथिंग, राइट? यू कैन सॉल्व क्वेश्चन देन, राइट? वी विल टॉक अबाउट एनर्जी, पावर, बिजनेस, ओके? एनर्जी क्या होता है, पावर क्या होता है, थ्रू ऑल द एलिमेंट्स, वॉट एवर एलिमेंट्स यू टॉक अबाउट, वोल्टेज, करंट, रेजिस्टेंस, यू नो, इंडक्टेंस, कैपेसिटेंस, राइट? और हम आपको एक ऐसा तरीका बताने वाले हैं कि आप कोई भी क्वेश्चन कर पाओगे, राइट? So please be available tomorrow. I will inform the timing. Thank you so much for today.